Hi friends, it's Kamal and you're watching Maths by Jajoria. Please don't forget to subscribe our channel. In this video, I will explain a quartic function. Okay, so the quartic function I will explain in this video. Now I have covered in my previous video about the cubic graph. So, and those who haven't seen that video, please, I will really recommend that you watch that. Before proceed with the quartic function or quartic graph, you can say as well. And I have also recommended my other videos on quartic factorization or other, graph for the linear equations, quadratic equations. So all that link I will actually have in my description box. So if not sure, please watch that first before moving to quartic function. Okay, so what is a quartic function, or you can say the quartic graph? It has a form ax to the power 4 plus bx to the power 3 plus cx to the power 2 or x squared and dx plus e. Okay, so you will get quartic graph in function, quartic function in this form. Okay, where a, b, c, d and e are real numbers and a is non-zero. So that's the important part, that this a is non-zero. Okay. A, B, C, D and E are real numbers. Okay. Now, one thing I would like to explain to you that we have covered different types of graphs for GCSEs and in the beginning as well as the AS as well. Now, you see in that videos, we use the standard method of completing the table of of values for the functions, any function we had, any equations we had. So in that we actually substituted x value in order to get y value. Okay, now this is a bit higher, like AS standard, AS level. It's different because in exam they won't ask you to draw in that manner with that method, rather use these method. Okay, so that's why the understanding of like cubic graph and quartic function or quartic graph is important. Okay, I hope you understand what I'm trying to say here. Okay, let's proceed with that. So first of all, you need to have a pretty understanding of a quartic function. So the graph of a quartic function can take several different forms depending on the exact nature of the function. Okay, so you see here these two these two graphs here. Okay, so for these two functions you find that a is positive. Okay, so that's your form here. In here a is positive. Okay, that is very important to understand. The reason for that is then you will see how the graph is behaving. Okay, and by doing so you can easily point out that with these two functions, these two different types of function, a is positive. Okay, now I will also explain here as well. If you have something like this, okay, it's a graph like this. Okay, what does that mean actually? Now if you see here like a two heaps yeah, on the x-axis, two heaps on the x-axis, that is repeated roots. Okay, I will explain to you what actually a repeated roots is when we do the example. Okay, but you just need to understand what exactly that means. Okay, this is here where these roots are distinct. Okay, this one here. Okay, and what this mean here is for this function you have a, this a is talking about, is negative. Okay, so remember that. Now usually what they say, they sketch the graph of a Quartic function by finding the roots of the function. Okay, this is what they actually ask. Right, so let's start. Okay, and have one example. Okay, so in this example we have y equal to x plus 1, and these are in bracket, and then you got x plus 2, x minus 1, and you got x minus 2. Okay, so this is your Quartic function. Okay, and we need to sketch the graph for this function. Okay, now as in the previous video as well, this is exactly the same method we use for the cubic function as well. Okay, when we had a cubic function, and this is how we, what was that? So we say when x is y is 0. So this is we say the set y equal to 0. So okay, so set y equal to 0, and solve to find the roots of the function. Okay, so why you need to do that? This is we need to do to find the roots of the function. Okay, just to mention that today I don't have my glasses. It's something wrong with the glasses, so I'm going through a new set of glasses. So that just slow me down in writing as well. So if you can please pardon me for that. Okay, right. Okay, so what we do now, we say, okay, as you say y equal to 0, so this is what we need to do. So we write then rest of the equation. Okay, so these are the equations now. These are the equation, and then you find the value of the x. Okay, so for that I can write individually for you as well. So what you can do is you can say, okay, x plus 1 equal to 0. Then you got x plus 2 equal to 0. Okay, like this, take individually. Okay, and then you got x minus 1 equal to 0 and x minus 2. Excuse me. Right, so then you know you got the x values. Okay, so with that you got x equal to minus 1, x equal to minus 2, x equal to 1, yeah, and x equal to 2. So once you have these x values, what exactly that means? So that means here the curve cuts the x-axis. So let's draw on that one. Okay, so this is your x-axis, and that's your y-axis. Okay, so let me write the coordinates. Okay, so it says the curve cuts the x-axis. So this is your x-axis, yeah, and that's your y-axis. Okay, cuts the x-axis at. So what we do, we start from here because this is minus, and then you go to positive side of this. Yeah. So in minus you have -2 and -1. Okay, so that will be your what your coordinate would be -2, 0. Okay, -1 and 0, 0 is your y. Okay, then you got 1 here, so then you got 1 and 0, and 2 and 0. Okay, these are your coordinates. Clear so far? And as we having these coordinates, we can also have this on here as well. So that's your -1 and that's your -2. That's your 1 and that's your 2. Okay, because this is what we need, right? So you know that we will use these coordinates. Okay, and for that you can say, okay, you will have like something like this. Okay, and then you'll have something like this. Okay, so you see we start to getting our graph. Okay, as you know that we haven't finished that, so what's next? Okay, so when x is 0, so we've done our y 0. Okay, so then what we say that substitute x equal to 0 into the function to find the coordinates of the y-intercept. So why we need to do x equal to 0? So that we can find the y-intercept. Okay, it could be this or it could be this. We will see what we get. Right. So substitute x equal to 0. Okay, into the function. Okay, yeah, and why is that? To find out the coordinates of the y-intercept. So for y, so coordinates for the y-intercept. Okay, and this is our equation, right? So we say when x is equal to 0, we have y, x is 0, so you got 0 plus 1. Okay, 0 plus 2, 0 minus 1, and 0 minus 2. Yeah, okay, so that what that will give us, that will give us 1, then you got multiply 2, then you got multiply -1, then you multiply, sorry, this is multiply, sorry. Then you got this. Okay, so just simply multiply this, please. Okay, and then all you have here is 2, and these 2, rest is your 1. But however, there's a minus sign here and there's a minus sign here, so that will make a positive number. And you got 2 multiplied 2, which is 4, and yes, so that will be y equal to 4. So you see, you got your x and you got y, so that is your coordinate. Okay, so 0 and 4. So the curve cuts the x-axis, sorry, y-axis at 0 and 4. So that will be here. That's your 0x, and that's your 1. You can say 1, 2, 3, 4. So it will go like this. Yeah. Okay. So see, we're getting that. So what's here is, so we can write down here. So the curve cuts the y-axis at 0 and 4. Okay. Right. Now, with this equation here, that equation, our quartic function, what we need to do, and this is I've done that, I have explained also in cubic graph as well. What we need to find after doing this, once we have a y value as a 0 and then x value as a 0, we need to check what happened to y for the large positive and negative values of x. Okay, this is, I have done that in cubic function as well as so as in quartic function as well. Exactly the same method. Okay, and what I will say to you, you can insert that value, okay, large value, okay, negative or positive values of x, and then you see what actually happened to the y. Okay, so I can give you one example here as well, where you say, okay, so I'll write down here first. So we'll check what happened. Check. So actually I'm writing this one, and this is what you don't need to do in exam. So but this is for you. Okay. The reason for that, I will explain to you why I'm asking you to do this. That is just for yourself to actually see what actually happens. So check what happens to y, okay, in your equation y here, okay. For large positive and negative values of x. Okay, so obviously what you do here, you're not gonna actually use that coordinates here, but just for your understanding. So I highlight that as well for you in red. Okay, sorry, ignore this. I thought I would be able to draw second one as well, so I just let's rub that out. Okay, right, that as well. And so I can write down here, so where you have x equal to 9. Okay, so what was your question here? So you can say that's your Quartic function. Okay, so this is just for you. So you insert this value in here, right? So you will get to like 10, then 11, then 8 and 7. Okay, so you see when you do this, I mean that's just a small value you increase. For the large value, you see the y value after multiplication of this is approximately this. So this is what you will get on the grid. So why you get this large value. So what actually here, what I'm trying to say, what I'm trying to implement here is that if let's say x approaches, I write in red for you, infinite, like infinity, the y you will also get in infinity. Okay, right? And then I also say to you that x approaches minus infinity, yeah, you will get y as minus infinity as well. So as I said to you that I leave that with you to find out, but the reason for this is to make understanding of this, that what exactly we get, and that for that reason you will see you will get your graph go like this as well, because that is approaching to infinity infinite. Okay, so I hope you understand this. Okay, so what I do now, move on to the next example. Okay, and see what we get actually with that. Okay, and what I will do with this next example, with the large value and stuff like that, this bit I won't go into that, but however, I will just say to you that check what happened to the y for the large positive and negative values of the x. Okay, and main reason for that is just to make understanding of this. If the x value to the infinity, what the y value would be, because that is very important, whether that will be positive or negative. Okay, and based on that, you get this part. Okay, this part. Okay, where that will go leads to. Okay, just to understanding of that, that's why important is, so that you can do that in the exam as well. Okay, I hope I make understanding of this. So let's move on to the next example. Okay, so one before I move, I will just like to show you here as well. Go back again, and here when I say on x-axis, the two heaps like this, like a curve, or you can say like a wave. Yeah, you see this? That is repeated roots. Okay, repeated root, and in here it says these roots are distinct. And also here, if you're going down here, that is a is negative. Okay, so here, as I was saying to you, that your a is negative. It says the a is negative. That's why you have in minus. So this is your y axis. Okay, however that you know that is all the coordinates here. That is your -1. In goes in minus. Okay, so let's do the second example now. Right. Okay, so in this one, I sketch the following curve and obviously and clearly show the point of intersection with the axis, something like that. So that's why they will ask you. Okay, so that is your y equal to x -1, and that is in bracket of whole square, and then you got x -3, that is also in your bracket with the square sign of it. Okay, so these two bracket square, okay, in that one. Okay, remember that. So straight to that, when y equal to 0, okay, when y equal to 0, okay, so that you will get like this. As I said that in this example, I will quickly show you. So you can do this, small bits and pieces yourself. So in this one, you will get what? X equal to 1, and you will get x equal to 3. Okay, clear that? And you have this as 1. Okay, x -2, okay, square, that is equal to, and that is also equal to 0, and this is what you will get, right? Oh, okay. Now, so with this, you know that let me make let me make this graph for you as well. Just give me one moment, please. Let me get my ruler. So let's make here, yeah, okay, and let's make x-axis and y-axis first, so we can pinpoint the coordinates on that. Okay, so this is, you got your x, and that's your y. All right. Okay, so the curve touches the x-axis at, so write down our coordinates here. With this is the curve touches the x-axis at 1 and 0 and 3 and 0. Okay, so you see here you got 1, 2, 3, so it will touch here and they touch here. Okay. Right, we'll come back to this later on. This is the points, and then what we will do, we'll say when x equal to 0. Okay, so with that we'll say when x equal to 0, your y will be 9 actually. Okay, so let's go with that. So when x equal to 0, your y. So this is your equation. That's your function. So okay. And what we will get here, that is 1, and that's 9. Okay, so your y equal to 9. All right, so when x equal to 0, your y is 9. So the curve cuts the y-axis at 0 and 9. Okay. So now sorry, before, so now we got the coordinates. These are our coordinates. You can say here, okay, so let's say this is 9. Yeah, right. So we know we got here coordinates, we got 1 here and 1 here. Right. Now before we draw this, something I have to discuss with you. Okay, so that obviously the make understanding of that, what I previously have discussed. Let me show you that as well. So in this one, let's go with this statement. The graphs of the quartic function can take several different forms depending on the exact nature of the function. So with the example we're doing, we have something like this kind of graph, but a is not negative. In this one, in this example, a is negative. In our example here, a won't be negative. Okay, so now before we move on, same thing here. You see here these two where coordinates where it touches the x-axis. These are both double repeated roots. Yeah, so I write down here for you as well. So these are, okay, so these are double repeated roots. Okay, so the curve will just touch the x-axis at these points. Okay, and how that would be? So it will be like this. Okay, sorry, if you take this one here, so it will be like this, right? So this is the shape you will get. I have 1 point here, 1 point here. Okay, because, and this we get because of 2, or you can say, so these are 2. Okay, so these are 2 double repeated roots. So double, okay, repeated roots. Right? Okay, and that's why I wanted to show you here that this is what exactly means here. Okay, now same thing here for the large value as I explained to you previously. So if you have x approaches to infinity, you'll find y as well. So these are positive numbers. So x positive, then the y will be positive as well. And so as your x minus infinity, then you get y is positive infinity. Okay. Now for that, as I was saying to you in the previous example, check what happened to the y for the large positive and negative values of x. Okay. So once you understand that, then you will know these as well. Okay. And also, I would like to say, with this function, the coefficient of x to the power 4 in the expanding function will be positive. Okay. Now, because that will be the positive, you will have your graph. So in here, we can cut like this. I'm sorry, because it's too close to that one. Okay, so what so this is a 9, but 9 here, but I should have cut like this. Okay, so let me just make it clear to you. Sorry about this. Okay. Okay, so let's say if your 9 is here, so it will cut like this. Okay, right, and then you have here, comes here, and then like a wave, like a repeated roots, and then you will see here these two. Make understanding of that. When x approaches infinity, y is infinity. When x is negative, the y is positive here. Okay, so even though your x approaches negative infinity, you still get y positive 1. So you will have your graph like this. Okay, and this is just like a mirror image of this here, what we have discussed previously. I hope you understand that. Okay, it just in this two examples, after substituting the y value and the x value, then you just need to make understanding of what happened to your y for large positive and negative values of x. Okay, so I hope it's clear to you, and in this example you also learn about the double repeated roots and how the graph will behave. Now do me a favor, if you are finding this video informative, please like and subscribe this video. Okay, be sure to click that like button and drop your comment if you have any question, and I will do my best to reply. Thank you.